For security teams, sifting through endless alerts is exhausting. The alert judgment agent in WuX AI can automatically monitor the generation of alerts and independently conduct analysis. It achieves full coverage of all alerts at 100% with an accuracy rate of 99.99%. Furthermore, it significantly reduces the workload associated with alert judgment by over 95%. Let's look at a real case of alert judgment. In this case, the AI combines the function characteristics of some code snippets from the original web shell alert information and the permission details from the web file to comprehensively determine that it is a real web shell alert. For this confirmed web shell alert, the questions we need to address next are: how was the web shell uploaded? What other malicious operations are performed after the web shell was uploaded? And whether any actual damage is caused. Previously, this type of work required multiple people from different departments to use various tools and analyze diverse datasets, often taking anywhere from several hours to several days to complete. However, in WuX AI, we simply need to click a mouse and provide the alert information as a clue to WuX AI, which then generates a multi-role, multi-agent security team to collaboratively complete the task. Within this security team, the judgment expert agent will analyze the web shell alert information, extracting the 1.jsp file as the initial investigation target and autonomously generating relevant investigation tasks, such as checking for additional malicious characteristics within the file content, identifying which process created the file, or examining whether there are other web shell files in the same directory. Upon receiving these tasks, the security investigator agent will independently determine how to execute them. In this case, it invokes a file creation query tool and eventually discovers that the web shell was written by a Java process. As a result, the Java process is flagged by our AI as a new suspicious object for further investigation. Next, we find a suspected host, 108.23, involved in lateral movement. This was identified through the web shell access logs, which showed that 108.23 had made numerous requests to 1.jsp during the alert timeframe. As a result, 108.23 also becomes a new suspicious object for investigation. In this way, the entire investigation process is dynamically expanded, much like a detective following one clue to another, unraveling the case layer by layer. With multiple investigators working in parallel, once all tasks related to investigating an object are completed, the judgment expert agent will summarize the findings. It becomes clear that 1.jsp had security issues and is subsequently added to the list of spoils. Multiple agents work tirelessly, cooperating with each other to conduct a thorough investigation. The investigation graph gradually becomes so complex for humans to understand. In just half an hour, they have completed the investigation of 184 objects, uncovering 36 backdoor traces, 1 C2 IP, 31 signs of compromise, and a series of data exfiltration activities. Additionally, we fully documented the critical attack timeline. Dealing with such a large number of alerts, organizing the investigation, leads alone, is labor-intensive. With AI, however, we can simply generate a summary with one click, producing a preliminary incident traceability report. This report summarizes information such as the alert timeline, targets of lateral movement, backdoor files, and more. But this is not enough. We need a more visualized report that offers more comprehensive information. Through the Report Intelligent Agent, we analyze the spoils and the timeline step by step, forming key frames of the attack chain. By combining this with some contextual information, we generate an overall attack path diagram, which can clearly display the attack process like a movie.